colour. And you end up sort of making it a bit more sort of difficult for yourself by inventing these sort of sensor attributes, hue underscore colour, hue underscore state, on and red for it. And then when you start to include, as well as actual sort of other sensor values, when I do, say, a retrieval there, bringing back the sensor name equals slider, get data equals true, that's going to get me the last known slider value. But it's the last known slider value of the entire database table. So if all you were sharing that database table, which is likely, if you're sort of offering a cloud-based service to all your customers, you only really want to bring back your particular value. So you need to identify who that user is. So in sending up that data, you need to also send URL, let's say sensor name equals motor, and sensor value equals, get data equals true, and then possibly send up a parameter for user ID. So sending through 3 parameters there for it to, and adjusting your SQL statement to match that. So you need to alter that to match in your server. Because currently, the SQL only searches on a sensor name and sensor value. Or inserts sensor name, sensor value, searches just on sensor name to it. So you need to include somehow that user ID. Currently, that user ID column in your tables is always set to be null. You'll need to pass over that sort of data. And it's not just sort of data you're passing over there, say, of a hue bulb to it. So you're needing to send over, if you're inserting a user ID, you might want to start sending over things like positional data to it. Your sensor might be in a certain geographical location. You might be wanting to send over units for it. Now, it can all be done using this idea of lots and lots of parameter names. You're making it more difficult for your user, though. Better if you could just say, send over for that URL the sensor data equals something, and store all your sensor data in one block, one little representation of your sensor data. Because then what you could have is a sensor object with things like your value, name, owner, the latitude, longitude, anything you want like units. You can have as many details in there as you like then, and send your data over as a JSON string. So that would be, well, actually it wouldn't be in double quotes. You just create a JSON string of one of those to send over. And then if ever your sensor changed, you wanted to add some values to it, you wouldn't need to change all these URLs. You're still just going to be sending over whatever that sensor data is. And you can use the JSON library to swap between a Java representation and the JSON string that you've got. Or the other way around, if you receive a JSON string, to translate from JSON string into a Java object, into a sensor object. So you've got it sort of ready there. It does mean you'll have to change a bit of your code. You'll have to change, say, in your look in your Phidget server. The usual thing that you've got in your sensor to DB. Inside your sensor to DB, which hopefully you're fairly familiar with now, you've got this bit somewhere where you're getting the parameter for a sensor name, you're getting the parameter for a sensor value to it. Now, if we just add more and more parameters, then yes, you can just add more lines in there, get the parameter for username, get the parameter for latitude, get the parameter for longitude, and then decide if it's not there and the like. It'd be a bit easier if you could just say, get the parameter for sensor data, and you'll pick up then a JSON string, which you can then dissect into the individual sensor name, sensor value, and use the rest of the code as is. So at that point, really what you want to be sort of doing is having something like, well, okay, well, let's pick up the sensor JSON to be whatever that thing is for sensor data. And then, out of that sensor JSON, I can create a sensor object from my JSON and figure out what my sensor name is, my sensor value, my position, etc. It just makes it a lot more flexible then. But you do have to change both sides. You have to change the receiver and you have to change the sender. The sender's got to send it in JSON, the receiver's got to expect JSON. And similarly, when you're sending it back, it's sending back JSON and the client has got to sort of accept JSON. So, whilst using the JSON package is fairly straightforward, it will mean a few changes. But by putting all those in, you'll deal with having your user ID. Because later on, you'll need to, when you update that sensor table, currently you're updating the sensor table with a name and a value. Really, you should be updating the sensor table with a sensor object. So that rather than passing X parameters, there are just passing 2 parameters, you'll want to pass a single sensor data one. And that insert there, I'm only actually inserting sensor name, value and time inserted. I'll need to modify that to insert the username and any other parameters. But change the method header, so rather than multiple parameters being passed, just pass one single parameter of the sensor object. Makes it a lot more flexible, a lot easier to sort of work with. Now, it's these sorts of things that make your code that much better. And that's the sort of thing that we're looking for in the things that are distinctive. You know, if you want a distinctive mark, if you want 80, 90, or 100% for that sort of thing, you're going to have to write distinctive code. So you're going to have to write good code, not just code that does the job, which is what I've given you. You need code that does it well. And that's this sort of idea, to bring some of these concepts in. So send and receive the data in JSON. Ideally have a sensor data object in Java to represent a sensor. I recommend you don't have a sensor.java class, because I think sensor is an object inside the Android development kit anyway to it, so it might get confused in its compilation when you do your autocomplete of auto imports and it brings in the wrong library. So sensor data, my sensor, or something like that to work with. Makes it very easy to change the structure of your sensor object later. Also, if you're using that JSON jar file there, because it's done at runtime, you've got to include that jar file in your runtime library. The same sort of thing that I was saying with MySQL. So you might find a problem of it saying on the server at runtime, can't find this JSON library. It needs to be in your webbing folder. The second part here about your clients, they should only be really receiving and sending your sort of sensor code to be sort of working with. And then there is a question as well about, do you even need to use a database? You can get by on this thing without using the database at all if you use MQTT. And just have this messaging service where you have a publisher that's just sending out to people who may be sort of interested in it. Now, we've done that just in the lab last week for it. So you can have a publisher broadcasting out when a lock status changes. That will get around that problem of polling the server from your actuators. Makes it very easy to do that sort of sections. One thing that it doesn't do is to archive away specific values. These things don't store the data. But it'd be easy to get around that, is to keep your existing code for the server to database and just have everything else working with MQTT and have a database client that monitors the state of your sensors. So as every time a sensor changes, you can just say monitor everything inside Nick's house. And then all these values come into your database client. And inside there, you can decide which ones you're going to put into the database, which ones you're going to archive, or perhaps aggregate out. You're saying, maybe I will only take the average of the last 100 temperature values, or I'll archive it only every hour. You can decide for yourself inside that database client when you actually write to the database. And using your existing database code, your database client can monitor these messages coming in and then write out as appropriate. Now that's what we did in that intelligent node processing lecture. I was talking about aggregating your data, smoothing that data out. Now yeah, people say, oh, that all sounds hard. It is. It is.